Okay, I'm coming back and doing example number 7 because it just got messed up on that video. So it said I wanted to find the common area here, and what I was saying at the end of the last video was that when we were, and I'm going to just erase this real quick so that you can look at this one. When we were doing this other problem and some of the others, we were trying to find this area. And we said that if we integrate from pi over 6 to 5 pi over 6, it would give us that. And you know how I showed you, it's only giving you, like, you know, what's up here. So we didn't have to worry about anything down below because of the way we were doing it. We were doing the outer minus the inner on our integration. And so it was only giving us this upper part. So if we took, we found out on the last video that this was also pi over 6 and 5 pi over 6, but it's a different area, okay? We're not talking about this up here, okay? If we were going to talk about that, if we wanted the orange part, it would have been the integration from pi over 6 to 5 pi over 6 of our 1/2, and the upper is the 4 sine theta squared minus 1/2 2 squared. Okay, that would have given us the orange, okay? And we don't want the orange, but I do want you to realize that these two circles are exactly the same. These circles are exactly the same. That means that that orange area is exactly the same as this red area. Okay, that's important because if we integrate from 0 to 2 pi, our 2 squared, sorry, 1/2, our 2 squared d theta, so 1/2 r squared d theta, that gives us the red and the green, all of it, okay? In fact, I'm going to take these lines out, okay, because I think you can see it better when you take those out. So if I integrate, that gives us the red and the green. Well, since the orange and the red are exactly the same, I now, because I don't want the red, right? I've got right here, I've got red and green. Red and green. But if I subtract off the orange, it's the same as subtracting off the red. So we are going to subtract off our integration from pi over 6 to 5 pi over 6. That outer, which is, and sorry, I'm going to put my 1/2 out front. Our outer, which is 4 sine theta. When I say outer, I'm talking about, you know, this outer, squared minus our inner, which is 2 squared. So we're basically taking the red and the green, we're subtracting off the orange, which is like the red, and we're left with the green. I hope that makes sense. So that equals the green. Okay, so let's do this problem. Let's do it in a nice color, I guess. So this is our example number 7. So we've got 1/2 integration from 0 to 2 pi of 4d theta minus 1/2 integration from pi over 6 to 5 pi over 6, 16 sine squared theta minus 4 d theta. So 1/2 4 theta from 0 to 2 pi minus 1/2. I can't integrate sine squared. I have to use an equivalency. So this is going to be 1/2 minus cosine 2 theta over 2. So this one, we can go ahead and say 4 times 2 pi minus 4 times 0. And this will give you 4 pi. Now, I could, well, let me add my like terms first. We could pull a 4 out. And now integrate. And when I'm integrating cosine 2 theta, I'm going to divide by 2. So this is just going to become -1 sine 2 theta. Now we're going to integrate it at 5 pi over 6, giving me 5 pi over 3 here, minus, and then integrate it at pi over 6, or calculate it at pi over 6, which is going to give you pi over 3 there. I'm writing too big. Sine of 5 pi over 3 is in the 4th quadrant, and sine is negative in the 4th quadrant, 60-degree reference angle. So this would be -√3 over 2.